right, so where do you see where it says muted? Yeah, I know, but it's not, it's just showing this farm symbol right now.
You're on. It worked.
Hey, Bridget.
Hey, John. How are you doing?
Pretty good.
Hey, Bridget.
Hey, Eric. How are you doing today?
I'm good. How are you, John?
Hey, how you doing, Eric?
Good.
You gonna talk about how you're gonna bring us some rain this week?
No.
Oh, what good are you then?
You guys didn't get any rain in like the whole month of June either. So
I know.
you're used to it. You're professionals at dealing with no rain.
I just cry. I just cry,
And that's a little bit of rain. So
but not quite enough.
Yeah.
did you guys start doing anything with your corn yet?
We don't do corn.
I thought you did.
We're strictly grass-fed beef.
Okay.
So we either have cool season grasses or we'll have millets or Sudan grasses. That's our whole farm. Our whole 360 acres is that way.
Gotcha.
Yeah. So we make our own baleage to feed our cows, and we make it off the grasses and the summer grasses. So that's it. Yeah. We don't do anything else. And, we're grass fed, so we can't use corn. People would freak out if they saw corn on my property. So that's what we do.
you guys all get your contracts today?
Yeah,
All that mail go through?
I got some stuff you sent me. I got to get that out to you.
All right, sounds good.
It
Yeah,
does.
it looks like I got an email from you, Bridget.
All right, perfect.
Hey, how you doing?
Making sure nothing goes to spam or something.
Thank you.
We can look to give everyone a couple more minutes before we get started. But thanks everyone for showing up. It looks like we're going to have a pretty small group today. I've talked to a couple people who are still actively making hay. So, but the recording, I'm going to record everything. So I'll share it with people who couldn't make it today. And we'll just kind of give Eric a chance to answer all of our questions, I guess. Eric, do you want to start out with a little introduction about yourself and your background?
Sure, sure. My name's Eric. I'm a certified crop advisor and owner of Rose Tree Consulting. So Rose Tree Consulting does integrated pest management and soil testing, precision ag type things. We write a lot of nutrient management plans and a lot of regulatory things as well. So we serve Pennsylvania and New Jersey. We have 8 people on staff right now. Probably by spring of next year, we'll have 9. 5 of us are agronomists, and we have some office staff. We have some part-time staff. So, you know, it's our job to go out in the field and look for problems and come up with plans. And that has kind of led me into becoming the executive director of the Pennsylvania 4R Nutrient Stewardship Alliance, and also serve as the executive director of the Pennsylvania Corn Growers Association as well. So, you know, my interests over the past couple of years have really been in looking how fertility changes when we move from a traditional, you know, way of farming into more of a regenerative ag type process where we're relying a lot on cover crops and where we're trying to do some green planting. So we tend to do, you know, 1 or 2 in-field trials every year, just us as a company, because we're so we have a nutrient stratification project that we've been doing for almost 20 years. So I can share some of that data with you tonight. We did a cover crop study last year where we harvested cover crop the day our customers planted green. And we weighed the nutrient concentrations in that and then tracked how those nutrients came back to our cash crop throughout the year. So we can talk a little bit about that later on tonight as well. You know, I thought what I would start off doing is just kind of going around the room here and just seeing what kind of questions you had about fertility, particularly in a planting green situation or any situation, and just make sure that we answer those questions. So I'll open it up and just let you talk.
Well, I'd be more than glad to start. So in our situation, we have about 300 plus acres that we use for rotational grazing. And that is where we not only, and we graze, we're up to about 200 head of cattle now, and we have more than enough to grow more. So what we do is come springtime, we have excess. By May 15th, there's excess hay out there, or grass than we have for cows. So around May 15th, we start making baleage. And our fertility is pretty simple. If we take grass off for baleage, we put back anywhere from a half a ton to maybe a ton of chicken manure. And that's what we do. And it seems to be working, but there's no other great rocket scientist to it. What I don't understand is people talking about cover crops and how they put things back into the soil. I don't understand how that would help us here, because typically if we put a cover crop in and we put legumes in to try and take advantage of the nitrogen, we're usually grazing that before the crop has a chance to fully express itself and produce the nitrogen in the soil. So maybe you could explain to me that I'm right or I'm wrong, because it's like, why would I want to spend, why would I want to spend more money for more different kinds of cover crops to put in to increase my fertility if I'm going to graze them before they get old? And the reason why I don't want them to get old is because the cows don't want to eat them, because then they're too mature, versus just putting a small amount of fertilizer to replace that. And that is, I guess, my main question in and what is the value of doing that in my situation? Is there still a value in that?
Anybody have an easy question? So that's a lot of questions there, John. And I think we can get into some of that as we go along.
Well, you asked me.
I did ask you. Yeah, I'm curious. Like, I'm generally curious, like what people's questions are when it comes to fertility, because unless we ask what the problems are and what your questions are, we don't know how to work to solve them. So, Raj, how about you? Like, when you think of your rotation and all the different crops you have going on, like, what's your biggest fertility question that you have right now?
Well, based on last week's seminar, he was saying that planting green, you really have to get the fertilizer in the slice and covered next to the seed for germination. Saying you really have to fine tune your planter. And so I wasn't really aware or thinking that way until last weekend. And so I'm thinking I'm going to have to revamp my planter, make sure everything's tuned up better. If you'd like to discuss that a little bit, that'd be helpful.
Okay, Mitchell, how about you?
Here. I got it. Okay. I think my biggest challenge is going to be getting through the planting green and getting it in the ground. I've been doing no-till long enough that I feel that the nutrients is there. I kind of have a longer no-till history, so I'm using that carbon breakdown. So that I found up front I lost that nitrogen and tied up my nutrients. As I went on, I've kind of gotten over that hump. So that's kind of, but I still have think I'm gonna have issues, you know, opening the slice and having enough pressure. So that's kind of where I'm at.
Gotcha. Jay or Derek or anybody else want to share? All right. Well, maybe you'll have questions as we go along. First thing I think I want to just ask everybody and just make sure that as you're moving into the whole planting green and working through this program, that you've got soil tests that are current within the past couple of years. I mean, does everybody have soil tests that are current within the past year or two? Because if not, like that's the first place we want to start. You know, from our perspective of working with our customers, if we have a soil test that's less than 2 years old, we're in good shape. As soon as we get a soil test that's 3 years old, where we're going into the third crop year on that soil test, we really struggle to figure out what our nutrient recommendations should be based off of that soil test. So make sure you got everything that's within a couple of years old. What we really want to focus on is we really want to focus on the pHs of your soil from that soil test. Remember that when you move into a no-till situation and now you're surface applying all of your lime, that limestone is going to leach down through the soil profile about 1 inch a year. So if you start off your no-till process and you've got a pH of 5.5, it's going to take you 10 years for that limestone to leach all the way down through the soil profile to correct your soil pH. So before you even go into the no-till situation, make sure that you've got your soil pHs where they need to be. There is such a thing as an acid shelf that people worry about when you go into a no-till situation, that you just continually apply your manure or continually apply your nitrogen fertilizer on the soil surface, and then it leads to an acid shelf. And that's not 100% true. I wouldn't worry about that too much as long as you're soil testing regularly and putting lime on as it's called for. So generally with our no-till clients, we're more looking at, you know, a ton of lime, 1.5 tons of lime every couple of years, just as a maintenance application, really. I like to see those pHs somewhere between a 6 and a 6.3. Now, everybody's going to have their own idea of what an optimal soil pH is, and I'm not going to argue with you on that. all I can tell you is when I look at yield maps, the people that have the yield maps for their corn, there's very little correlation between soil pH and yield. You can find the highest yielding point in the field, and that's not the highest pH. Sometimes it's the lowest pH. There's just very little correlation there between high pH and high yield. So what we've learned from these yield maps and from collecting data over the years is that as long as we can keep that soil pH within the ideal range, that we don't have free floating aluminum in the soil, and that our hydrogen levels are kept to a minimum, that our yields are going to be maximized. So 6 to 6.3 is probably all you need to do when you're just growing corn and soybeans. Now, as soon as you put vegetables into the rotation, you might need a higher pH. As soon as you start to transition from like a row crop situation to a forage crop situation, then you might start looking at those calcium levels a little bit differently. But just from a corn, soybean, wheat, grass hay type rotation, 6.3 is really all you need to be. But keep in mind that when we're in these no-till situations, that leaching thing happens very slowly through time. That an inch a year is really all it's going to take. So if you're in that no-till situation like Mitchell is, and he's been there for a long time, you know, he's probably just has pHs that are ideal because of frequent lime applications and allowing that calcium carbonate to leach down through the soil profile.
So Eric, I got a question, Eric.
Yeah.
You're talking about soil tests. Is there a benefit for grid sampling versus just doing a good test? Or that versus pulling a good test, good sample, I guess I should say.
Grid sampling is useful when maybe you don't have a whole lot of soil variability in the field. So we find grid sampling useful when we have big fields that are flat.
Okay.
And you don't have a whole lot of natural soil variability where it's, you know, stony on one side or 100 feet higher on the other side. As soon as we get into highly variable soils, we tend to go more towards using a plant health image based soil test, where you can do it in granular, you can do it in climate field view, where you outline your field boundary, and then you're basically making a planting prescription solely based off of plant health imagery. And you create that zone however you want to make it up, and then you can go out and soil test that zone, and then you can import the data right in, overlay it, and then make your prescriptions based off of that. We can do that a whole lot more effectively, a whole lot more efficiently and cheaper than we can do grid sampling. And when we compare the two practices, grid sampling versus like a modified zone, we can get really good information with that modified zone. So for a lot less money.
Yeah.
We've compared it to using the Varus technology, where we create zones based off of Varus versus just using satellite imagery, and we get pretty close. So yeah, I would say that if you're looking to go above and beyond just a basic soil test, just start looking at your plant health images. And there should be a fairly good correlation between your zones that you want to manage and what those plant health images are showing you.
Yeah, I know I have some fields that are variable soil types, so that makes a big difference.
Yeah, whatever you do, never soil test based off of the NRCS Surgo soil maps. They're just not accurate enough. They're great to look at, but the accuracy of those things is way off. So I would advise you that if you want to take that next step into precision, I would start with plant health imagery, because almost everybody who's going into precision has some kind of service that offers them plant health images. Use them. They're pretty helpful.
Okay.
So that's my story on limestone and soil testing. The other thing I would add is micronutrients. We have a lot of customers that ask us, are you testing for micronutrients? How are we handling micronutrients? And I have two thoughts on that. The first one is, if you're not willing to spend the money on micronutrients, don't test for micronutrients, right? Just save that money. If you're not the person who's going to go out and add zinc in with your potash, or add boron in with your potash, then don't spend the money on it. If the other thing that I would say is, if you're super concerned about micronutrients, you really should be doing plant sampling to determine what your micronutrient needs are, because simply the presence of those micronutrients in your soil is no great indicator of what's actually getting into your plant. You know, we see plenty of times where sulfur levels, boron levels, zinc levels in the soil are good, but there are certain growth stages where we're just not getting plant uptake of those nutrients and we have to supplement with some other things. So me personally, I tend to lean towards not sampling for micronutrients a whole lot. I tend to lean more on our plant sampling to gather that information and know what I need to do on micronutrients. If you're just raising corn and soybeans, like when you're growing corn, go out and take a plant sample when it's a foot tall, send it to the lab, look at what your micronutrient levels are there. That'll tell you how to adjust your starter fertilizer. Make easy adjustments next year to address that. If everything's coming back okay and within the optimal range, then you're good. You don't need to spend any more money on those micronutrients. So Pennsylvania can send them to Penn State. I think Rutgers also has a plant sampling lab that you can easily send your plant samples there. And any of the commercial labs out there would be happy to set up an account just for you that you can send your plant samples to. We send ours to Waypoint. Waypoint has a location in Virginia. They have a location over here in Leola in Lancaster County. And you can overnight those samples, and really within 24 hours, you'll have your results. It happens that fast. So anyway, that's my story on soil testing, which morphed into plant sampling. What's the sense of the group here? How many of you are doing plant sampling?
Before we go any further, I have a question. My name is Brad, by the way. Name on the screen here is Phyllis. That's my wife. But
You can go by whatever name you want to.
yeah, you can call me anything you want. I respond to a lot of different things. I don't have current soil samples on the fields that were picked for this study. So I'll get some soil samples this fall. If, for instance, it looks like I need lime, should I apply lime now? Should I plow it in? Should I leave it on the surface before the cover crop goes in? And how much preparation should I plan on doing? The fields that were picked were relatively small. We're only talking, in my case, a few acres.
And I'll just jump in that you're doing sweet corn and pumpkins. Is that correct?
Yes, that's correct.
And roller crimping. Just.
Yep. I didn't was not able to listen in on last week's program, so I'm blank on that. I don't know what was discussed.
Okay. I would say that if you take your soil test and the pH comes back above a 5.8, I think we can just surface apply that line and let the leaching work through time. If it comes back less than a 5.8, I would probably lean towards trying to do some tillage, as long as that tillage is consistent with Bridget's program.
Okay. I have been applying leaf compost for quite a few years. So I'm not too worried about micronutrients. The work that Rutgers has done on leaf compost tells me that there's micronutrients in the leaf compost, and I use a lot of tonnage. The higher organic matter from leaf compost also tends to kind of buffer the soil as far as the pH goes. So soil tests will tell, but I think that's where I'm at. I'm actually applying compost to the sweet corn field now. As sweet corn's getting picked, I'm cutting down, mowing down the stalks and applying compost, because I didn't apply that field last year. So I'll probably have to do some tillage anyway.
Okay. As you guys get your soil tests, if you have questions about them, send them over to Bridget. Bridget can send them to me. I can take a look at them, and I can give you, my opinion on a course of action. In the leaf compost situation, Brad, I would agree with you. The buffering ability of that compost, I would be surprised if you had any pH issues. I think in your situation, knowing that you're going into sweet corn or you're going into pumpkins, I would get the micronutrient tests on that. I'd be curious about, well, the magnesium will come in your regular soil test, but I would be curious about some of the other micronutrients as well.
Okay.
So are you doing any kind of plant sampling for your pumpkins?
Not for the vegetables. I have an apple orchard and we do soil and plant tissue tests every year in the orchard, but I haven't been doing that for the vegetables, no.
Raj, how about you? Or what are you doing for your pumpkins?
I'm in the same spot. I need to get soil testing done right away and then find out if we have to apply lime. I don't think lime's been done for 2 or 3 years. So I know we're due for soil testing and starting this program. So we got to get it straightened out and get on the right program here.
Okay. Okay. Any other questions online before we move on?
Yeah, and I just want to reiterate too that if you guys don't want to speak up, you're welcome to also write comments in the chat. You can push that little chat button at the bottom of the screen, little dialogue button, and I'll be sure to bring them to Eric's attention. But it's a really small group, so I mean, Jay, Derek, you know, Jeff, feel free to kind of jump in.
All right. Next thing I had on my list that I wanted to bring up was starter fertilizer. And I break starter fertilizer down into two areas, right? You've got the pop-up fertilizer, and then you've got your banded fertilizer, almost kind of like an planting application. You know, generally from a pop-up fertilizer perspective, if you're planting really early, if you're the person that's going to go out there in April when soil conditions are cold, I always recommend using a pop-up fertilizer or some kind of starter fertilizer on that. As your soil conditions get warmer, you know, as you maybe start planting more into May, we just see less and less of a return on investment from that starter fertilizer application. That by the time our customers are planting in mid-May, we're just not seeing yield increases or really any kind of growth difference from the use of that starter fertilizer, that pop-up fertilizer. So I kind of tend to shy away from pop-ups after we get past that mid-May date. April plantings, definitely like to see some pop-up fertilizer there if it's an option. Other starter fertilizers, like if you're doing a 2x2 placement or if you're just dribbling nitrogen on off the side of the row, I really do like that. More and more as time goes by, we see our customers putting some amount of nitrogen on off the row. It used to be that they had a separate coulter on their corn planter, and 4 inches off the row they could put up to 30 gallons of nitrogen on that planting. And now today you don't see that coulter. You see basically two streams of nitrogen back off the row on either side of the closing wheel, you know, right on the soil surface. So instead of a 2x2 placement or a 4x4 placement, now we're seeing that nitrogen a 2x0 placement. And the response to that has been really well. We've seen good increases in people who are adopting it, and we've seen maintaining of crop yields for people who are transitioning from that 4x4 placement over to a 2x0 placement. So I really like putting nitrogen on at planting. It slows you down, I get that, but we do see a really good response from at planting applied nitrogen. As you guys move into a green planting situation, that at planting nitrogen becomes more important. You know you're going to have a cover crop out there that is going to have some ability to immobilize nitrogen, meaning that if you go out and you broadcast urea on a cover crop, or you go out and you do your burn down in 30 gallons of nitrogen, yep, sure enough, that cover crop's going to die with that 30 gallons of nitrogen plus gramoxone, but the biomass that's there, in order for that to break down, is going to require nitrogen. So the microbes that are breaking down that cover crop are going to grab the nitrogen that you just put on, and you can be left with an immobilization situation. Best way that we found to avoid that is to put that nitrogen on with the planter, either right behind the row as a dribble or inject it 2 inches off the side. And we like to see about 50 to 60 pounds. So in cases where people are using dry fertilizer and they're planting green, we'll have them use a 50-50 blend of urea and ammonium sulfate, put that on at about 150 pounds. Where people are using liquid nitrogen, there again, we like to see sulfur in the mix. We'll go with a 28%. Some people will go as low as a 26%, depending on where they're sourcing their nitrogen from. And then we're in that 15 to 20 gallon range at planting. So then that gives them somewhere between 50 and 60 pounds or 50 and 60 units of nitrogen for their crop right when it's planted.
Eric, there are a couple people on this call right now that are organic. What kind of options do organic farmers have for kind of that early nitrogen application?
That's a good one. We have a handful of organic customers that we work with, and generally they are planting late. They're not the earliest planters out there. They're waiting for their cover crop to grow so that they can plow it down. And generally they've got a healthy dose of legume in that cover crop to supply the majority of their nitrogen.
Mm-hmm.
We have one or two people that are tinkering around with organic starter fertilizers, mostly in the pop-up type fertilizer where it's being placed right on the seed. We do have a handful of people that are getting a custom dry blend to put in with their starter fertilizers or in a 2x2 placement. It's really the same concept, but a little bit differently. Like we want to make sure that we have nutrients placed right by the seed so that during those early growth stages where there's no deficiencies. And you can do that through a pop-up, you can do that through a 2x2 or a 4x4. It's really the nitrogen thing that separates the organic farmers from the conventional farmers. The conventional farmers can easily go ahead and just put nitrogen right in the corn planter and have very good success with that type of management strategy. In an organic situation, it's not the same. I mean, you can get some nitrogen, it's on the expensive side, but generally we see our customers using the starter fertilizer for micronutrients, where they're going to get a custom blend from Fertrell or TMAC or whatever fertilizer company that they're dealing with, and that's going to go in the planter in a 2x2 placement.
Okay.
So how do you guys have your corn planters set up right now?
So I'm currently have a dry system on mine. So are you thinking that I could release the pressure on the fertilizer discs and put that dry on the surface? Is that kind of what you're saying?
I think you'd have to stabilize it.
Okay.
Liquid on the surface, we tend not to stabilize because I feel like we get really good soil contact immediately. You start putting urea and ammonium sulfate on the soil surface, I think you're going to want some kind of a stabilization product with that.
Yeah. And you're not talking about ESN at all in that?
Not talking
Wow.
about ESN at all in that. I'm really just talking about straight urea and ammonium sulfate. I want available nitrogen. I don't really want it tied up.
Okay.
For that particular application. Later application where we're doing a broadcast or a top dress, yeah, the ESN potentially could be a good fit.
Because I've been using a 3-way blend broadcast quite a bit.
Yeah, Nutrien likes to do that. They like to do a 30% ESN, 30% urea, 30% ammonium sulfate. And they've been having really good success with that on corn and in wheat as well. For a starter fertilizer application though, I tend to go just urea, ammonium sulfate. I just want available nutrients and I want them there right away when the plant needs to access them. So,
Yeah, I'm set up with just the dry fertilizer on my planter too.
so yeah, the other question then, and it kind of stems back to what Mitchell had said, where if getting the seed in the ground is an issue in a planting green situation, getting the fertilizer in the ground could also be an issue in a planting green situation. It's probably more of an issue for the fellows that have dry fertilizer than it is that have liquid fertilizer. We have dry fertilizer on our corn planter down at home, and we have the same issue. where there are times where we can get the seed in the ground just fine, but the starter fertilizer kind of just gets placed right on the soil surface. And we just get our urea. It's a urea ammonium sulfate blend. We get agrotane put on it just to help with some of the volatilization losses. Because in that particular situation, I'm more concerned about, above ground losses, volatilization, than I am below ground losses like leaching. So I choose a nitrogen stabilizer that's just going to be more positioned for volatilization losses, which would be like an NDPT type product, which is agrotane. So anyway, that's what I would do. I would just get a 50-50 blend urea ammonium sulfate, put agrotane on it at 150 pounds, and use that as your starting point and see what happens. So any other questions on at planting stuff? If you guys really want to see a good, I think we had talked about it last week with Steve. We were kind of mentioning different resources. Beck's Research puts a book out. It's like their PFR book. Every year they put out it's like their research book. And it's a great read. It's about 100 and some pages long, but what they'll do is they'll go through and they'll rate all of the different trash wheels, and they'll rate all the different closing wheels, and they'll rate the different fertilizer delivery systems, and they'll rate the different fertilizers, for a pop-up type situation. That's a great read. I download it every year. I distribute it to all of our employees, let them read over it. It's very useful. It's just a giant meat sandwich full of information that you can use to help make decisions on your farm. So I always push people to take a look at that before they make decisions on how they're going to modify or change their planters to put fertilizer on.
What's the name of that again?
So Bridget just put it into the chat. It's bexhybrids.com PFR report. So it's a PDF that you can download and look through, and yeah, I like it. It's interesting read. So all right, next thing I wanted to talk about. We talked about the at planting nitrogen, and kind of the reason we want to do at planting nitrogen is really to talk about that nitrogen tie-up that sometimes happens with cover crops and planting green. And I do want you to realize that nitrogen tie-up from a green planting is real. All right. And even in a situation where you have a mixed cover crop, and this would pertain to organic situations too, where you just have a whole lot of biomass, particularly as the carbon to nitrogen ratio of that biomass increases, it's going to tie up nitrogen in your soil. That can or cannot be a problem depending on how you manage it. For our conventional people, the easiest way to overcome that nitrogen tie-up is to do that at planting nitrogen. But I do want to reassure you that even though immobilization and nitrogen tie-up is a big deal, by the end of the year, all the nutrients that are in your cover crop are pretty well released back into your soil. So the other year I told you we did a kind of a research trial on that. And what we did is we picked out 5 of our customers who were planting green. And we went to them and said, look, we've got as many questions on planting green fertility as you do, and we'd love to try to set up a trial to answer some of those questions. What questions do you have? So we kind of interviewed all 5 of them and came up with a plan that the day that they planted green, we were going to be there. We were going to harvest a square meter of cover crop, send it to the lab, and get it analyzed for the nutrient concentrations that were in that cover crop the day they terminated the cover crop or the day they planted, and then follow that through the whole season. And what I can tell you is from our 5 participants, and some of them were north of Route 80, and some of them were in Lancaster County, and some of them were in Berks County, and some of them were over towards New Jersey. We tried to have a fairly good geographic representation for this little project. The average biomass production the day that they planted was 11.5 tons. Okay, so that's just pure forage. John, that's not 65% moisture, or it's not taken down to 15% hay moisture. That is, we cut it off, we weighed it, with all the moisture in it, there was 11.5 tons of biomass that were present in the field. Average. Sometimes it was 5 and sometimes it was 20, depending on the mix that they had. So when we're planting green, there's a big difference in how you set your planter set up to manage 5 tons of residue versus manage 20 some tons of residue. But what we found is with that average 11.5 tons of biomass that were produced by the cover crop, there was 100 pounds of nitrogen that those cover crops had taken up from the soil and were storing. All right, so that's a pretty big deal. 100 pounds of nitrogen captured in that cover crop is great. It's 100 pounds of nitrogen that through the course of that cover crop growth may have leached, it may have volatilized, it may have been lost by some other pathway. That cover crop caught it. So that's great. 100 pounds of nitrogen in that cover crop. If you know much about forage production, you would know that if you want to get a pound of nitrogen into a forage crop, you pretty much need 1 pound of potassium in that forage crop as well. So while on the day of termination, we had 100 pounds of nitrogen in that cover crop, we also had 100 pounds of potassium in that cover crop. And if you think about that, 100 pounds of potassium in that cover crop, and you did a calculation to figure out how much potassium corn is going to remove, that's enough potassium for 230 bushel of corn. That's enough potassium for probably 10 tons, 12 tons of corn silage. That's enough potassium for a whole wheat crop. That's enough potassium for half a year's worth of hay. And all that potassium was sucked out of the soil and now is living in the cover crop the day that you kill it. So that's a huge issue, because if we get into a situation where we don't have microbial breakdown of that cover crop fast enough, you may see potassium deficiencies in some of your crops. And from a corn and soybean perspective, I'm not all that worried. But if Raj and Brad, if you're out there no-tilling pumpkins, that's going to be something that you're going to watch very carefully, because pumpkins are going to have a very high demand for potassium. And if we have a cover crop that is doing what we want a cover crop to do, we're going to need an extra 100 pounds of potassium on there to compensate for what that cover crop is doing for us. So how we kind of handle some of what we learned from this project is, in our high value crops, we want to elevate that potassium level up to the high side of what the university recommendations would be. For the rest of us, it's kind of fun to know that our cover crop is getting 100 pounds of nitrogen and 100 pounds of potassium. It's also getting about 30 pounds of calcium, about 6 pounds of magnesium, 8 pounds of sulfur. It's got a little bit of copper, a little bit of zinc, a little bit of manganese. But what we really learned from that initial sampling is that, oh my gosh, watch your potassium levels pretty closely when we move to a green planting, particularly if you're starting to bump the rates of those cover crops up to produce high amounts of biomass. That potassium is going to be a slight issue. The next thing we did is, in this project, is we went back, and once we sampled that initial sample, we filled up laundry bags full of cover crop and we threw them back out in the field. And we just let them weather, just like your cover crop naturally would. And then every month we would stop back, pick up a bag, send it to the lab. And what we wanted to see is, we wanted to see the rate of return from those nutrients. That if we started off with 100 pounds of nitrogen and 100 pounds of potassium, how fast does that nitrogen and potassium leach out of the cover crop back into the soil? And from what we learned, when we terminate the crop, all of our participants terminated this crop in May. So when we went back and grabbed the June sample, and we took the June sample and sent that to the lab, 2/3 of the potassium was already out of the cover crop. Okay, so now when you're thinking about pumpkins, or you're thinking about tomatoes, or you're thinking about some other kind of high value crop, you really have to watch out for that first month to 2 months of growth when it comes to potassium. Once we get past that 2-month stage, we've got over 50%, over 50-60% of that potassium that's leaching out of the plant back into the soil. What we found is nitrogen is a slow burn, where that potassium leaches right out of the cell wall back into the soil fairly quickly in the first half of the growth season. Nitrogen is more metered. Nitrogen comes out at almost an even rate the whole season long. So if you've got 100 pounds of nitrogen sitting there in that cover crop, You can say that you're probably not going to get a whole lot of nitrogen return the first 30 days, but then later part of June, later part of July, that nitrogen starts to slowly move out of the cover crop and will continue to move out of that cover crop through August and September as well. All the other nutrients, pretty much exactly what you would expect in terms of the macronutrients. I got to say, one of the goofy things that we found, and I really can't explain it, is calcium did not leach out of that cover crop. Over the first year, we actually saw calcium levels increase in the cover crop residue. We saw micronutrient levels increase in the cover crop residue. So all that tells me is calcium and micronutrients do not leach. They do not leach out of the cell wall. They do not leach out of the lignin or whatever you have going on in that cover crop, but they're only going to become available as microbial degradation allows them to become available. So through time, we do want to keep an eye on some of those micronutrient things. We do want to keep an eye on some of our calcium availabilities. And, you know, like I said, it's more of an issue in those high value crops, pumpkins, tomatoes, any kind of, you know, non-row crop type thing. That's where I think we want to watch it a whole lot closer. So that's the first thing I wanted to run past you in terms of, you know, after you get done planting, maybe what you want to watch for. We do want to watch out for how these cover crops are returning nutrients to our soil. I can tell you it's probably not a huge problem, but it is a problem that you want to watch out for. Next thing I'd want you to keep a kind of attuned to is the nutrient stratification thing. So once you surface apply your fertilizers and now you've planted your crop, how fast does those nutrients move down through the soil profile? Talk about limestone. You know, limestone is going to move about 1 inch a year. Potassium is going to move about 6 inches a year, and phosphorus is going to move about that far in a year's time. Phosphorus is going to move about 1/2 inch in a year's time. So what we found is that when people transition from conventional tillage to no-till, that stratification happens immediately. You know, you can take a soil test the year 1 that you transition from conventional tillage to no-till, and everything looks great. And then you can take a soil test in year 3, and you've got stratification levels like you wouldn't believe, where you'll have potassium levels that are about 60% higher in the top 2 inches of the soil versus the bottom couple inches of the soil. And that happens very rapidly when you transition to no-till. But what we found is we've been doing these stratification samples on the same farms for 20 years. And they're all farms that are continuous no-till. They're all farms that have regular applications of manure. They're all farms that take forage. What we found over 20 years is that that rate of stratification becomes less through time. That initial transfer period from conventional tillage to no-till is the worst stratification you're ever going to experience. You know, years 5 through years 20, the stratification kind of comes down and becomes less and less as that potassium is able to leach down through the soil profile, as some of your other micronutrients are able to leach down. That you know, this fall, we'll actually redo our stratification samples. We do them every 3 years. But back in 2017 or whatever, our stratification had already decreased by about 30-some% compared to what it was after that initial transition from conventional till to no-till. So I do want you to watch out for stratification. Where stratification is going to come into play for the majority of you is in that potassium area, because there again, potassium leaches out of our cover crops because it's water soluble. Right? So it leaches out of our cover crop onto the soil surface. It's where we put all of our potassium fertilizer. It's where we put our manure. Unless we get water, we're not going to get leaching of that potassium down into the root zone. And not only that, if we get our corn 12 inches tall and we get into a dry spell where we don't get rain for 2 weeks, you're bound to see potassium deficiencies because the soil is so dry in those top couple inches that the potassium is locked up. It's not plant available because there's no water. We see that all the time. Continuous no-till, you get a dry spell when the corn is a foot tall and you're out doing plant sampling, and before you know it, every single plant sample you take comes back deficient in potassium because it's dry. So keep an eye out for that. The stratification thing is real, but I don't think it's anything that you need to change a lot of management over. It's just something that I think you need to monitor. any questions on the stratification or the cover crops returning nutrients to your fields? That's a lot to take in. So, all right. Next thing I wanted to talk about, it really deals with small grains and corn. And that would be just making sure that however you're designing your fertility program for planting green or incorporating cover crops, we definitely want to make sure that you're doing split applications of nitrogen through the season. All right. So split application of nitrogen is you put 150 pounds of urea ammonium sulfate on at planting, or you put 15-20 gallons of nitrogen on with your planter, and now you're going to go out and put some nitrogen down with your burn down, because why not, right? You need to have some kind of a carrier for your burn down fertilizer, so you're going to put that in 15 gallons of nitrogen or 20 gallons of nitrogen. But keep in mind that corn crop, and the same thing could be said about a wheat crop. To get that corn out of the ground to knee high, I need 30 pounds of nitrogen. All right. So you putting 150 pounds of starter fertilizer on, you putting 10 to 15 gallons, 20 gallons of liquid nitrogen on that planting, that application is enough to get your corn plant out of the ground to past knee high, because we only need 30 pounds. It's just the way the plant is designed. Once it gets past that knee high growth stage, it's going to take about 7 to 8 pounds a day to go from knee high to tassel. It has an exponential growth curve or an exponential uptake curve when it comes to nutrient uptake in the plant, that by the time we get to knee high, we better make sure that the majority of our nitrogen is in the soil and plant available. And the best way to do that is to look at some kind of a split application where you've got a little bit of nitrogen on up front with your planter or with your burn down herbicides, but we're saving the majority of that nitrogen for a side dress application when the corn is 12 inches, 15 inches tall. We got to make sure that it's on and that it's in the soil and plant available before that crop gets knee high. So my knee may be a different height than your knee, but you get the drift, right? And it goes back to that nutrient uptake curve. If you've ever heard me talk before about nutrient uptake, I always have a slide on the screen where it talks about nutrient uptake. And it's really a bell curve. It starts off low, and then you have this exponential uptake, and then it kind of evens off a little bit. From a corn perspective, I definitely need you to understand that 30 pounds up to knee high, but then 7 to 8 pounds a day through the next couple of weeks. That's a critical thing to understand. And next thing I need you to understand is that today's modern hybrids probably take in about 20% of their total nitrogen after tasseling. So in all of the crop scouting that our team does, we never see a nitrogen deficiency when the corn is knee high. We never see a nitrogen deficiency when it's waist high. We see our nitrogen deficiencies post-tassel. So if you want to go out and evaluate your nitrogen fertilizer practices, that's the time to do it. You got to get out there post-tassel during grain fill, the month of August, look around for leaves on the bottom that have that inverted V, and then figure out what's going on. Generally, what we find is that if we're able to do that split application, we're able to do a side dress application, we don't see those nitrogen deficiencies. Mitchell, I'm going to go back and talk about the ESN urea ammonium sulfate blends. I tend to see more deficiencies late season with that mix than I do a liquid application. I don't know if your experiences would be the same.
I wouldn't say so, but I don't I figure that ESN gives me 60 to 90 days out. That's why I use it. It gives me an extra time window. And then if I think I'm got a good crop or I'm going to need more, I can always top dress more at that time. So it actually almost gives me a third application window. But the ESN gives me my second window. I don't have to apply it. It's already there. I can put urea on at the time that's available, and that gives me a little longer extension. That's kind of my management.
Yeah, I would say from my experience, I really like being able to split apply the nitrogen or have some delayed nitrogen available to the crop. The ESN, and I think it's more of an application issue than it is a product issue. But sometimes it seems like the ESN is applied with too much force, and the little plastic polymer gets ripped off as it's flying through the air. Sometimes I feel like they don't get close enough to the edge. I feel like we get more.
Sometimes the ESN isn't good quality to start with. Too much shipping.
Yeah,
I've seen that.
Yeah, I support their product. I think it's great technology. I just haven't seen as consistent results with it as I've seen with liquid products.
Yeah.
So, but yeah, I mean, from a side dressing standpoint, I think we all should be side dressing our corn. Like I said, it takes 30 pounds to get your corn from out of the ground to knee high. I don't ever advocate that people only put on 30 pounds at planting, because there's always those times where side dressing seems like a great idea when we're sitting here in September, and then you actually have to go out and do it in June, and it's not such a good idea because it's raining and you can't get in the fields, or you got a whole bunch of other stuff going on, your sprayer breaks. There's always reasons why side dressing maybe is a bit more complicated than it should be. So I always tell people I want 50 to 60 pounds of nitrogen total on up front between your corn planter, your sprayer, whatever else you're doing. I want 50 to 60 pounds of fertilizer on up front, even though it only takes 30 to get me to knee high, and you should have your corn side dressed before knee high. I just want a buffer. I want the flexibility that if things don't go totally right, that we can get in a little bit late and we're still not setting our crop up for deficiency situations.
So are you talking a side dress of urea or a side dress with drop tubes on a sprayer? Or it doesn't too much matter?
Most of what we see is liquid side dress. I would say the majority of the people that we deal with are doing it themselves, and they're doing it with liquid. Out our way, Nutrien is doing a lot with dry side dress. Growmark is doing some. ChemGrow is doing some dry side dress. So I do see a good bit of dry side dress. I still think
Because currently all my side dress is dry. I'll either get it spun over the top or have Growmark come in with a high crew. So.
Yeah, they would rather do the dry because they can cover more acres in a day's time, and you can't blame them for that. They have efficiency issues as well. From a growth perspective, I just think we see better results from the liquid.
So are you using straight tubes or Y tubes? Does it matter?
We have a handful of people that are using Y drops. Most of the people that are using Y drops are actually doing multiple split applications, where they will do a standard split application when the corn is 15 inches tall, but then they're going to save the last 50 to 60 pounds or the last 10 to 20% of their total nitrogen load, and then that's going to be a Y drop application, and more of that Y drop application is a variable rate Y drop application based off of plant health or yield maps. So, but yeah, I would highly encourage everybody that if you're not side dressing your corn, tinker around with it, see if you notice a difference in yield. We've been really happy with the results. So, any questions on side dressing?
Does what you're saying also apply to sweet corn, same as it would field corn? Or are there any differences?
Yes and no. Sweet corn, matures so much faster. Under plastic, I think we need to put it all down dry. Some of the bare ground sweet corns, particularly the later planted ones that aren't harvested till August, September, I think we can do a side dress application. People that are growing commodity crops like corn and soybeans, we really worry about every pound of nitrogen and the cost of that pound of nitrogen. Most of the people I work with that are growing sweet corn are not really worried about the cost of 1 pound of nitrogen. That we tend to make sure that it's got all that it needs. I do agree with what Steve said last week, that over fertilization is a problem, but generally on our sweet corn, we're putting a lot more down up front and relying on the side dress a little less. It's still being done. It's still being done in conjunction with a couple of foliar applications, where it's a little bit of a different situation. But I would say overall in sweet corn, we're over fertilizing by a little bit, but we're also relying more on an upfront broadcast. So is that consistent with kind of your production methods?
I'm not sure I have production methods. Sweet corn is something that I added to my cropping probably 5 years ago. Just started growing sweet corn. So, you know, I don't have years of experience at looking at different things. It's still fairly new.
And I would have a similar thought on pumpkins as well for both you and Raj, that we definitely see more of our pumpkin growers doing a split application, where that second application is you know, a reapplication of potassium, a reapplication of ammonium sulfate, and some other nitrogen sources as well. But we're timing that to right before it binds, and having pretty good success with that. So next thing I wanted to hit on, you know, we talked about just doing some soil testing and just making sure that we've got our starter fertilizer and planting stuff set up, and then making sure the split applications, if it's feasible to do a split application, we're finding a way to do that. The next logical thing that I'd want you guys to think about is when we talk about pre-emerge applications versus split applications, the question usually arises is, should I use some kind of a nitrogen stabilizer on any of these applications? Everybody and their brothers out there trying to sell you a nitrogen stabilizer for different applications, right? Like every fertilizer company has one. Usually if it's a proprietary product, the margins on them are so high, they're very profitable to sell. So like really everybody wants to position a nitrogen stabilizer for you to use. You know, the nitrogen stabilizers, if you go back and look at the research on them, every single one of those nitrogen stabilizers is compared to ammonium sulfate in terms of how effective it is to reduce volatilization when leaching. So think about that. Everything is compared to ammonium sulfate, meaning ammonium sulfate is really good. So Mitchell, when you're using your three-way mix of ammonium sulfate, urea, and ESN, or if you're putting ammonium sulfate in with your starter fertilizers, ammonium sulfate's great for reducing nitrogen losses. We just don't see the losses from that particular product. Problem is, it's expensive as all get out. So we try to minimize how much ammonium sulfate we use. We usually try to use no more than 100 pounds in our blends. But so then it comes to the nitrogen stabilizers, and then you have a choice. Are you more concerned about nitrogen that volatilizes up in the air, or are you more concerned about nitrogen that leaches down through the soil profile or becomes denitrified because of waterlogged conditions? And that's a question that only you can answer, but it's a fairly simple one. Do you have wet soils that hold moisture? Do you have sandier soils that you know you're going to have a lot of drainage? Or do you have surface applications and you're really just worried about volatilization up in the air? So that's the first question that you need to ask yourself. And usually people have a strong opinion, one or the other, which one they're concerned about. Sometimes people are concerned about both. My particular situation with the soils that I deal with most of the time, I'm more concerned about volatilization. Most years I pray for enough rain that we have leaching losses. I'm really concerned about volatilization in the soils that we work with here in Eastern Pennsylvania and Northern Jersey. So I want to make sure that we get products in place or that we're managing our nitrogen in a way that's going to minimize losses from volatilization. So if we're injecting nitrogen at planting, we're putting it 2 inches off the row on the surface in a dribble, or we're putting it below the soil surface in a dry starter fertilizer blend, ammonium volatilization is 0. We don't have to worry about it. So unless you're the situation that I'm in, or the situation that Mitchell had talked about, where that dry starter fertilizer, sometimes it's getting in the row and sometimes it's getting on the soil surface. That's the one place where I would use a nitrogen stabilizer. But generally, from my planting applications, I'm not using a nitrogen stabilizer. My broadcast applications, I am. If I'm broadcasting my nitrogen, and that generally is me putting my burned down herbicides on in 20 gallons of nitrogen, I make sure I use a nitrogen stabilizer in that situation. I've got 60 to 65 pounds of nitrogen going out there that if I don't have a stabilizer on, half of that's going away in 5 days if I don't get rain. So that's a huge risk for me to take if I'm not using a stabilizer. So any broadcast application I make like that, I'm making sure that I have some kind of a product in place. So you've got the NBPT, which is the volatilization products, that's the Agritane. You've got DCD out there, which is the leaching agent. So Guardian is a DCD product that you might be pretty familiar with. And then there's some products on the market that have both. The new Agritane product has both. There's actually a new chemical on the market called Duramide, which again is going to work on volatilization. So make sure that you're using one of those in your broadcast applications. I will caution you, read the product labels, because one company's NBPT product is going to be completely different from another company's NBPT product and the percentages that they put in that product. We notice the exact same thing with DCD. If you buy DCD from one company, it's this percentage. If you buy DCD from another company, it's this percentage. You know, like it's like this percentage versus this percentage. Always watch the bottles to figure out what you're getting in that product and that you're using it correctly. But definitely for broadcast applications, make sure you're using some kind of a stabilizer. When it comes to those side dress applications or those top dress applications, if I'm using a liquid and I'm side dressing a liquid when the corn is knee high, I'm probably not using a stabilization product. Simply because I've got corn that's a little bit taller to buffer wind, and I'm putting it in a thin band, which is making it less susceptible to wind and volatilization losses. If I'm using a dry product for a top dress application, if I'm using a three-way blend, or if I'm just using urea, I'm always putting a nitrogen stabilization product in with that blend. We've got too much nitrogen going out there on a broad surface, and there's a lot of exposure to wind, there's a lot of exposure to sunlight. That's a situation, again, where you put that nitrogen out there and you don't get rain in 5 days, you've got a very large percentage of that nitrogen moving off site, not into your corn crop. So keep that in mind. The stabilizers definitely have a place. I don't think they fit in on 100% of the acres all the time, but know the situations where you're going to be exposed to losses and make sure you've got a stabilizer put in place there. So any questions on that?
I just have a question on theory. How much of that 7 pounds do you figure you're getting from residue? That 7 pounds of uptake a day? Residue or cover crop residue?
Yeah, that's a good question. Depends on the soil, depends on the management,
okay.
Depends on their organic matter content, depends on the cover crop content. That's the great unknown right now when we're looking at nitrogen management in corn. We know it takes a pound of nitrogen to produce a bushel of corn. That hasn't changed. How we get there has. You know, we have people that are producing a pound, or we have people that are producing a bushel of corn on 0.75 pounds of nitrogen, applied nitrogen, because they're able to take into consideration what their soil's providing, what the residues are giving them. They're able to quantify that. And that's really the great unknown for us as we move forward with soil health. We don't have a great way to quantify what that soil's contribution is. Is it 20 pounds? Is it 30 pounds? Is it 100 pounds? Even take an organic situation where we.
I was just going to say it's more important when you come to an organic situation. Yeah. It
is. Like we have organic customers that they'll take wheat off and they'll underseed that wheat with clover. And next spring, like the clover is the most beautiful stand of clover that you ever could imagine. And they plow it under and they plant their corn and they're like, what's my yield going to be? And we have no idea. We have no idea. Is it going to be 80 pounds? Is it going to be 100 pounds, 120 pounds? Yeah, like it really can run the gamut between like 80 and 120, depending on different parameters within the field. I think you're starting to see answers for that come about, you know, as you can use some of these nitrogen modeling tools. AdaptN is on the market. Granular is on the market. Some of the other companies that are out there have their own proprietary nitrogen modeling platforms, but I can tell you AdaptN and Granular are pretty much the only two. Anybody else who's running a nitrogen modeling program is running a platform on top of one of those other ones. But those nitrogen modeling programs are pretty fun. And what it does is you go out and go out in April and take a soil test. And it'll tell you what your nitrate levels are. We want to know the nitrate levels in your field in April. And we plug that into the model along with the cover crop, the percentage cover, the biomass production, what your organic matter levels are, how much manure you applied. We put in what your fertilizer strategies are going to be. And then it cross-references all that with your corn maturity and the weather that's occurring through time. And that's been a really great way for us to answer some of those unknowns when it comes to soil contributions to fertility.
How much is that service, Eric? Is that expensive?
It tends to be, it depends on what you're adding onto that service. So
Okay.
AdaptN, you as a farmer can go and sign up for AdaptN and get your own account. We use AdaptN on some of our customers' farms. It works out pretty well. Granular is a little bit different, where Granular is a company that is really based on data management. So you would use Granular to manage all of your yield maps and all of your variable rate applications. And then Granular has a nitrogen add-on on top of that. So the Granular platform in itself tends to be more costly because you do that base granular product, and then you add nitrogen onto it. Actually have my Granular t-shirt on today. It just so happens. So we use Granular too. We use both of them. We have confidence in both of them. They're pretty fun programs to use. It's really interesting that when you log onto your account and you look at your fields, and it'll tell you field 1's deficient in nitrogen, and you think to yourself, I was just in field 1 last week, it's not deficient in nitrogen. And you go and look, and sure enough it is. That's about how accurate it is. We've been really surprised with the level of accuracy with these programs to identify nitrogen deficiencies. So we like them. We're actually doing a program next year where we're going to be doing nitrogen modeling on cover cropped corn fields in all throughout Pennsylvania. And the goal is to be able to prove the concept of nitrogen modeling that NRCS can then offer that as part of a CSP bundle. So you'll be hearing more from nitrogen modeling. You'll be hearing more on that from us over the next year as we try to work through some of those kinks and get the nitrogen modeling to a more acceptable place.
Interesting.
So that's probably probably the biggest thing, where if you're going into cover crops and you're going to be relying on cover crops for the majority of your nitrogen, and you're willing to do a side dress application if needed, definitely look to using an adaptive strategy like an AdaptN or a Granular program. Even though you have to pay for them, they can easily save you that money upfront. So even if you said that you were going to use a Granular platform, it was going to cost you $10 an acre. And wow, $10 an acre seems like a lot, but that's all of your yield map management. It's any of your variable rate applications. It's taking all your varieties and plugging them in, a lot of data management stuff, and you're going to add nitrogen on top of it. You can easily make that $10 back faster than you think. So AdaptN being just a nitrogen program is probably around that $3 an acre. So that's something where if you yourself, you're like, I don't really want to manage data, I don't even have a yield monitor, but it's kind of interesting what you're talking about. Try the adapt-n thing. You can try it on 100 acres. You can try it on 50 acres. You can share an account with your neighbor. It's fun information to use. So, but yeah, if you're really interested in quantifying nitrogen contributions from cover crop, I think that's the best road to take.
That's good.
So, any other questions? So I had kind of an agenda written down of everything I wanted to cover, and I just looked at it and I covered everything, except for, well, I wrote down John's question earlier, and I conveniently forgot to answer that. So, so John, your question was on cover crops. How do cover crops put things back in the soil? And I will answer that for you. Cover crops can put nitrogen back in the soil. Nobody's going to argue that with me. That's about the only thing a cover crop is going to put back in the soil. Everything else a cover crop is bringing up from the depths of your soil that was lost to the root zone. You will find when you do soil stratification samples that if you can get your soil probe down deep enough, you will find a layer of sulfur or a layer of calcium down there that your plant roots just can't access. And the theory behind cover crops is that you get something that has a seriously long root system that can dive down deep into the soil profile and bring those nutrients back. That's how people are looking at cover crops as putting things back in the soil. It's really just bringing them from a low depth and returning them to the top where they can be plant available. And so then that comes to your question is, well, wouldn't it just be cheaper to go and buy those nutrients? And if we're talking about calcium and sulfur, the answer is yes. That even if you have a cover crop that's bringing up a little bit of calcium or bringing up a little bit of sulfur, is it enough? Me personally, when I think of cover crops putting things back into the soil, I'm focused on nitrogen. We did a study a couple of years ago where we took a handful of our farms that have a nutrient management plan, like the CAFOs, the regulated farms. They've got a nutrient management plan. They have to follow that nutrient plan. And what we ended up doing is we went out into cornfields at physiological maturity. So throughout tasseling and grain fill, right? So newer hybrids today, 20% of that nitrogen is going into the plant after tassel. But as you get into mid-grain fill, the roots start to die off and the plant starts to shut down. And as the roots start to die off and the plants shut down, it stops taking in nitrogen. So you have this declining nitrogen uptake as plants go through the grain fill period, particularly as the milk line forms and starts to work its way down. And by the time you get to black layer, there is no more nitrogen going in through the roots of your plant. So that allows you to go out and take a soil test at physiological maturity and figure out what your nitrate levels are. And then understand that the only two ways that those nitrate levels get there is over fertilization and what your soil is contributing to fertility. And what we found is we took all of our CAFOs that were in this project. We went out, we soil tested their fields for nitrate, and we found that the average, and this is people that are implementing a nutrient management plan to the best of their ability, the average had 60 pounds of nitrogen present in their soil at physiological black layer. So that's
talking leftover.
Leftover.
Yeah.
Leftover. So that's the question. Is it leftover? Right? You hope it's not leftover. But what if that 60 pounds is your soil just cranking because the soil health is so great? You've got microbial activity, you've got nitrogen cycling happening in your soil like you wouldn't believe. And as that plant is starting to shut down in August, you still have conditions that are just highly favorable for microbial activity. And throughout the course of that last month, late August going into September, your soil is producing 60 pounds of nitrogen that's out there. And you're going to harvest your crop and walk away from that 60 pounds. That's where I think cover crops are going to play a bigger factor in that. Right? If I told you there were 60 pounds of nitrogen out there, if I told you that was akin to spraying 20 gallons of nitrogen across your fields, you would know exactly how much that cost, right? All right, 60 pounds of nitrogen times, just take $210 UAN, that's 37 cents a pound. 37 cents a pound times 60 is what, like 15 bucks an acre? You've got 15 bucks an acre of nitrogen just sitting out there waiting for you. You put a cover crop out there, I've already showed you that between when you plant it and when you kill it, you're gonna have 100. So sometimes, there's a good opportunity there to use a cover crop to just keep that nitrogen within the system. And I think that's where the cover crop really helps. But now it comes down to simple economics. Can I put a cover crop out there to save $15 of nitrogen, or can I put a cover crop out there to save $30 of nitrogen?
Well, I mean, look at it from this perspective. Let's say that I need 70 acres of ground to produce, and I'm going to grow, say, like a sorghum Sudan grass, and I need that 70 acres to produce enough food for my cows for the next winter. So I plant a cover crop going into late August. I may graze it a little bit in the fall, and then I'm taking it out in the spring. It's a cover crop using, all your brassicas and turnips and your triticale, whatever. But it's not really something that you would make a crop out of. Or you take 35 acres, half of it, and instead of using the cover crop, plant, say, maybe a oats, annual rye, triticale mix. Going to fertilize both crops. You can maybe graze off your oats in the fall, but you take your triticale and rye for feed in the spring, take them out, plant your sorghum Sudans. But now, since you've double cropped it, you now have used less acreage to get what you need to feed the cows, but you've spent more money on fertilizer for doing all that. So what I'm interested in this whole research thing is where am I better off being? Because until this program came, I was always of the opinion I would just plant the rye, triticale, and then I would go and plant my sorghum and use half the acreage. But now that's why I'm wondering, well, how much less fertilizer would I may or may not use? Is it even worth doing that? And that's kind of what I'm trying to understand from this program.
You read articles about the guys out in the Midwest, like the upper Midwest, that are doing a lot of cattle grazing on cover crops. And they seem to be doing it with not a lot of inputs. And the question I always have is, what's the price of land? What's the price of their commodity? What kind of competition do they have? Because I think the answers to those questions are severely different for New Jersey than they are for North Dakota.
Yes.
The situation that you guys are under with land rents and competition for land and just being able to pay the taxes on the farms really probably pushes you into an intense production area that I would focus 100% on forage production as much as I can. If I had to buy nitrogen fertilizer for it, you've got to have the production to support 200 cattle. Because if things work out right, you're going to have 220 next year because you can sell them.
Right. That's what we're trying to learn from this research is to see what that would be, because it's not just for me, but it's for people who do similar things that I do, to see which is the better way to go.
Yeah, we have a handful of people that are grazing cropland. It seems to be in the lower land value areas. I don't have many people that are grazing cropland in Lancaster County, Lebanon County, where land rents are $300 to $500 an acre. We have people grazing cropland in northern Pennsylvania, where land rents are not that. Western Pennsylvania, where if you had $40, you could rent just about anything you wanted to. Those areas we see more grazing, but they tend to have, the acreage isn't limited.
Mm-hmm.
Yeah, that's a tough one. I think it's more of your business model. and what your business model's telling you.
Yeah, but we're happy where we're at. This is just an experiment to see, which way it works out. Because people do ask us questions, and we get a lot of people come and tour our farm and ask these questions. And, I am a dealer for a seed company, and this stuff is important because, like, people ask me that question I asked you, well, if I use this cover crop and I use these legumes, can I reduce my nitrogen fertilizer? And I don't have an answer for them because I don't know, because there's so many things at play, and I'm trying to learn all these things, and it's not readily out there what the real answer is, because there's so many things that it depends on. So I don't know. I really don't know what's the best answer for them. So I just kind of do it myself just to kind of see what happens. So I at least have some kind of an understanding of what's going on.
Yeah, I generally think that if people are growing wheat and they take the wheat off, they put a mixed species cover crop in, I would say a third of the people that we have in that situation are taking wheat off, and they're putting in a forage crop to harvest. Like, they're going to take a cutting off of it in the fall. The other 2/3 are just doing a multi-species cover crop for soil health. The people that take the forage off in the fall generally go high clover amounts. So they'll take a cutting of clover in the fall. Come spring, that clover comes roaring back, and they'll wait till it comes in the head, and we figure 100 pounds of nitrogen off of that.
Mm-hmm.
Where that really becomes profitable is the forage crop they took off in the fall. Really sets it over the edge.
Yeah, but you have to wait. I mean, when you say it goes to head, you're probably waiting until June, aren't you, for that to really take effect?
It's up north of Route 80. It's late May. Late
Okay.
May while that's happening.
All right, so for us, it may be more like mid-May then. Well, that's doable.
So then are they going back to the silage corn on that, or a grain corn?
Mostly grain corn. Yeah. Yeah, that particular situation's worked out really well. After the wheat comes off, they'll wait a month. They'll do a bushel and a half of oats, 10 to 15 pounds of crimson clover, half a bushel of wheat, and they'll take oats off in the fall as a forage crop. Then in the spring, all the clover comes roaring back, the wheat comes back, and by the time they're planting, the wheat is headed out, the clover is headed out. It's a when we talked about the cover crop biomass that we had done in our projects, that particular site was not quite 20 tons of biomass per acre. It was a lot. So 2019, they had great success with it. 2020, not so much. It was too dry. They couldn't get the seed in the ground.
Mm.
So anyway, any other questions before we wrap up tonight?
And I also just want to reiterate, for those of you who, maybe other questions come up, that Eric is part of this study. He is kind of on call to help out with any kind of nutrient management or herbicide questions you have. So, feel free to take advantage of that service, because it's a pretty neat opportunity. So
Yeah,
you
if you
should all
want
have
to hear me babble, just give me a call.
Yeah. Anyone else? No? All right. Well, thanks everyone so much for tuning in, and thanks, Eric, for sharing your expertise. I always learn so much.
We'll talk to everybody later. Have a good night.
Thank you.
Good
Thank
night.
you, Eric.
Have a good
Good
night.
night.
You.
Thank you.